when you're solving a trigonometric equation by factoring, it's really no different than solving a quadratic equation by factoring. And so our first step is going to be to set our equation equal to 0. So I've gone ahead and already done that. I've added the 1 over. Now, if you have a hard time factoring, it's often useful to rewrite the problem just using x's. And so I've done that over here in red. I've replaced my signs with x's. And so to factor this, since there is no greatest common factor and I have a number that's not a 1 in front, I'm going to use the box method to factor, okay? And so, you don't need to do it with the x's, but I think it's usually helpful to do. So a quick recap on the box method. First term in the first box and last term in the last box. Multiply those together and I get a 2. The numbers that I finish filling out the box with need to multiply to 2. And at the same time, still add up to the number in the middle, so add up to 3. And so the two numbers that will do that are going to be 2 and 1. And it doesn't matter where those go, but they do need x's with them. Hopefully this is no-brainer at this point. We've done so much factoring over the last few years in high school. And so now to finish this, I'm going to look across rows and columns for greatest common factors. Well, the biggest number I can get out there is 1. Up here, I can get an x out. Going up and down the columns then, I can factor out a 2x. And then just a 1 over here. And so my factors for this, if it was quadratic, would just be, or if it was just with x's, would be 2x plus 1 and x plus 1. And so now taking that and translating that back into trigonometry, I see that this trig equation would factor very similarly. It would factor to 2 sine of theta plus 1, and then sine of theta plus 1 equals 0. So if you can factor the quadratic, you should be able to factor the quadratic trigonometric equation just as easily. And so now, since I have two things being multiplied together to equal 0, what I know is that either this is equal to 0, so 2 sine theta plus 1 is equal to 0, which I'll solve that in just a moment, or sine of theta plus 1 is equal to 0. Okay, and so there's the two equations I want to solve with really nothing different than what we've done earlier. And so getting sine of theta by itself, I'd subtract 1 and divide by 2. I'm going to do that all together and just say that the sine of theta is equal to 1/2. And if you need help with this part of the problem, I'd recommend going back and watching a previous video. And so using my trig chart, what we've done before, I can see that the angle that gets me a sine ratio of 1/2 is pi over 6, which may or may not be an answer, so don't circle it yet. Really, it's just a reference angle. And so what I want to do is I want to figure out the two quadrants where sine is negative, since my sine ratio is negative this time. And so looking back to that ASTC thing we've talked lots about, I can see that this happens in quadrant 3, sine is negative. So I'll draw my reference angle in there, pi over 6. Sine is also negative in quadrant 4. So I'll draw pi over 6 as a reference angle in quadrant 4. And so then remeasuring these counterclockwise from the positive x-axis, I would get my two first answers to this problem. Each of those angles would come out to be, or one of them would come out to be 7 pi over 6. If I remeasure that, hopefully you're just fine with measuring those at this point. And then the second angle, since it's a little bit less than 2 pi, I'd subtract pi over 6 from 2 pi to get 11 pi over 6. So there are my two first answers to this question. Let's go ahead and take a look at the other side of our little green squiggle there and find out if we have any more solutions. So maybe this is true as well, so this could get us more answers. Sine of theta plus 1 could be 0. So subtracting 1 from both sides, I get sine of theta equals negative 1. And then looking in our trig chart under the sine column, I'd see that that ratio is 3 pi over 2, which is a quadrantal angle. So this whole like drawing it into two different quadrant stuff we did doesn't apply. The quadrantal angles are not in a quadrant, they're on the axis between quadrants. So there's only that single solution there. So I end up with 3 total solutions that's on this interval between 0 and 2 pi.